the displacement, maximum stresses, and the reaction using an analytical approach. Just to make a quick revision, I have calculated in that the displacement, the reaction, and as well as the stresses. So these are the two displacement which I have calculated for a certain points, that is at a distance of 2000 mm in this bar. Okay, and similarly for 4000 mm I have calculated the displacement. Okay, so then after that, as the bar being a constant, it is having a constant cross sectional area, so the stress induced I have calculated, so that is 10 Newton per mm square, as well as their respective reaction. So this is what we have covered in our first introduction tutorial. Now in this tutorial, we will go for the method number 2, which I call it as a numerical software based approach. Numerical itself, but here I will try to focus using the software. That is, as my focus is with regard to Ansys, so we will see how we can use the Ansys software to solve this same simple problem. Again, here using the software approach also, I will be calculating the same variables like displacement, maximum stress, and the reaction. Now, when we see the Ansys software, there are different module involved. As a package, when you see this commercial software, you have different modules. So in that, the two prominent you will find, that is the Ansys workbench, another is the Ansys APDL. Now coming to this problem, if you are getting it out, which can we use? Can we go for Ansys workbench, or can we go for Ansys mechanical APDL? Let me tell you, we can apply both these software modules. It is quite suitable, as our problem being simple static analysis. So we can use both Ansys workbench as well as Ansys mechanical APDL. Now when we see each of this software module, if I follow the Ansys workbench, the first step, I need to create a model. For that, Ansys workbench has having its own designer, that is Ansys designer module, where you model it. Then you need to specify, the next step is the material property, whatever it is there, it is having a Young's modulus, so steel, so that you need to do. Then mesh it, then you need to apply the boundary condition, that is one end is fixed, another end applied with a tensile load, and you are able to get the respective field variables, that is displacement, maximum, reaction after the solving. So this is the Ansys approach. Now in this tutorial I will go for the Ansys mechanical APDL. The reason behind that is that I understand my problem, since it is being a simple bar subjected to a tensile force. If I look into the Ansys APDL, there are some elements available in the library which I think it is quite suitable. I can use it and can analyze the problem. So in that sense, I will be going for the Ansys APDL software module. So each software module, whether it may be Ansys workbench or Ansys APDL, it has the 3 steps, that is pre-processing, solution step, and the post-processing. As I mentioned regarding to these 3 steps also, yes, the pre-processing is nothing but where you create the model or the problem, mesh it, applied the boundary condition, that is what we call it as a pre-processing step, step number 1. And in the solution, it is automatically done by the software, so no need to think, just you need to run the command solve in the Ansys software, so automatically the software will solve all the respective, I can say you, the stiffness matrix for this problem, global stiffness and everything, and finally it will results in the solution solved. Okay, then finally the last step after, when you do the step 2, that is the solution, once you run and your solution is done, in the third step is nothing but the post processing, where we will find the displacement, maximum stress, and the reaction in this bar. Okay, so as I told, I will be following ANSYS APDL. So we will see a simple approach with regard to ANSYS APDL, how we will solve this problem. Okay. So as you see, now I have opened the ANSYS APDL, where I will do the first step, pre-processing. What I told in the tutorial, I will create the model, mesh rate, apply the boundary condition, and everything. That is the step number 1, that is the pre-processor step. The next step is the solution, which is automatically done by the software itself, nothing to do. It automatically, once we run the program, it will run and we will get a final solution depending upon our correct whatever, if you have applied a correct boundary condition. So that is the step number 2, solution. And finally the general post processing, where the interpretation to our simple problem we will follow, then we will do. So the first step, pre-processing, where I will select the element type. So I will click on that, then add. Here there are different types of elements are available, but as with respect to my problem, since it is a bar subjected to tensile force, so I will select link 180. I have gone through the characteristics of this element. It is also element having tensile plus compression characteristics, and it is quite suitable to our problem. So I have selected the element link 180. So just I will close this. After that, I will specify the real constant. Real constant in the sense, I will specify some cross-sectional area, and for my problem 60 millimeter square is the cross-sectional area. So I have specified the cross-sectional area to the element, okay, whatever I have selected. So close. After that, then I will specify the material property to the model, since our problem being structural, linear, elastic, and our material is steel, isotropic. So I will specify the Young's modulus. So I have specified my material properties. So this is this point number 3, you can say material property. Now comes the modeling. There are different approach you can follow. You can create a 3-dimensional model, mesh it, and you can do everything, the boundary condition steps and all. But I follow one simple approach in terms of nodes. Means I will model my geometry in terms of nodes. Why? Because I feel it is a simple problem. So I can do this way also. You can do a 3D also. You can create a model. There are different approaches of modeling. By area, by volume, everything, then you mesh it and you can do. But as I have understood the problem, so I will try to create in terms of the nodes. Means I will just create first for my problem the nodes. That is the first node I will specify, this is my node number 1. If you not specify also, randomly the Ansys software, it will take the node number 1, which is 0 0. Apply. So I have created my node 1. Then node number 2, I will just create at a distance of 2000 mm. So this is apply. Then when I apply, I have created my second node. Similarly, I will create the third node at a distance of 4000 mm. Okay. Now why? Because I have finished. I think for my problem 3 nodes are sufficient, and that's why I close this. Now if you see, these are the 3 nodes I have created. Now for these 3 nodes, I will create the element, and that is through nodes. I will select this node and this node. I have created one link 180 element. Similarly, between 2 and 3 nodes, I will collect another element. Why I have followed this approach means in my next tutorial I will follow the same, analytical FEM approach where I will formulate the stiffness matrix for their respective elements and node I will calculate. So that is why I followed to model my problem in terms of nodes and element. Now I have created my geometry. Is it meshing is required for this? No, it is already, it is in terms of nodes and elements. So now I will not do any meshing steps here. So directly I will go to the load, I will apply the load. So I know one end of my bar is fixed. So for that I will select the node option, I will select this node. Okay. Now once I select, if you see there are all degrees of freedom ux, that is translation along x, translation along y, uy, uz, that is translation along z, all that. But I will select the first option, all degrees of freedom. Why I have selected to this node all degrees of freedom? Since this end is fixed, it is fixed, it is not having any degrees of freedom. Generally a node will have 6 degrees of freedom, that is 3 translation and 3 rotation. In simple, if I say more detail I will tell in my coming tutorial. So in that regard, all that 6 degrees of freedom I have constant. So that is what I have selected. All degrees of freedom means it cannot move in x direction, it cannot move in y direction, it cannot move in z direction. Likewise, it cannot rotate in x direction, it cannot rotate in y direction, it cannot rotate in z direction. That is what it means, all degrees of freedom. Now I have specified the first boundary condition, that is the displacement. Now I will apply, why? Because there is only one force at this node, that is the free end. So I will apply. So the force is along my x direction and the magnitude is 600 Newton. So I have given the value of 6. Now if you see, I have modeled my geometry. So with that, as I told, my first step, creating the geometry, meshing and applying boundary shape, I have completed. This is the pre-processor step. Next, solution. I need not do anything since it is being a simple structural problem. So just I will go current, LS means current solution. So I will just run this program. So we will see. Now once this message appear, that means that your solution is done, you have solved it. Okay, and this will give you a detailed description about your problem, how it is there, what are the condition you have applied. Okay, some information. So just we will close this. So we have done the step number 2, solution also, we have solved the problem. Now we will see the post processing step. In the post processing, what we did in our analytical approach also, where if you see, remember, just I will do quick, where we have calculated the displacement, then the stress and the reaction. Similarly, for this Ansys approach also, I will try to show you the 3 variable itself. So first I will try to show you the reaction. So for that, list results, go in the reaction solution, click all items, so that you will get all the reaction flows. If you see very clearly, this is my node number 1, minus 600. Same thing I have done in my this. If you see, this is the only end we will get the reaction force. Okay, why? Because this is a fixed end, and when the force is applied at this point, so at this end only you are able to find the reaction force. Same thing you are able to get in the Ansys approach also. Same at node 1, there is a minus. Why? Because it is opposite to the force, so it is minus 600 Newton. And other, if you see, y direction it is 0, z direction is 0. So the total value of the reaction is minus 600. So in that way we got the first variable, that is the stress. So that is the reaction I have shown you. Now I will go, then I will show you the nodal displacement, okay, for this problem. If I click on this, now if you see here, okay, if you see, these are the node numbers. Node number 1, there is no displacement. Why? Because it is fixed, all degrees of freedom. Ux, as I told in the beginning itself, when application of boundary condition, ux is equal to 0, uy is equal to 0, uz is equal to 0. But node number 3, if you see, we got 0.1, and node number 3, 0.2. Similarly, in the analytical approach also, I have calculated and showed you at the distance of 2000 mm, 0.1 mm, at a distance of 4000 mm, which is being this end, free end, we got 0.2 mm. Okay, so in that way we have got the for the displacement, nodal displacement, okay, for the at the respective nodes. Okay, so this is the we got the displacement variable. Now coming to the last one, that is the stresses. Okay, we will see what is the elemental stress induced in this. So for that list we will go for the elemental solution. In that, stress is there, you can get many types of stresses, but I will go for the elemental stress. I want to see what elemental stresses are induced in these two elements. So if you see here a detailed description, as we got in the analytical, you can see the stress is 10 Newton per mm square constant, both the element. If you see, this is element 1, okay, and this is element 2. Why? Because it is having a constant cross sectional area. So we have calculated that stresses, so you can see the stress, we can find it. Okay, so this is the elemental stress what we got in our analytical approach, that is 10 Newton meter. Same thing we are able to get in the software approach. Okay, so this is all about just likewise you can get many feed variables. Just I correlated now in this the using the software. If you want to get again a colorful image, that can also be analyzed and that can be there, but until you are I will show you just this is the displacement which you can get. This is the maximum displacement. Why? Because this is the free end. Okay, like that whatever you are interested to know in this the field variables, that is maybe stress, reaction, or the displacement, or any other terms, you can able to get it. Okay, so this is with regard to the software approach we are done. Now just I will make a correlation what we got in the analytical, that is method number 1, that what we got in the software approach, that we will see it. Okay, so that you will get a clear idea what we have done in Ansys as well as in the analytical. The respective field variables, if you see here, these are the displacement, exactly the same thing what we got in our analytical approach. We got the minimum displacement, and this is at the free end, that is the maximum displacement what we are able to get. This is the displacement what we got. Okay, same thing I have just shown you some colorful image how where it will be. If you see, this is the free end. Why? Because this end we have applied the force, and this end is the fixed end. Okay, where the bar is fixed. Okay, so that is why you can see the free end, there is a maximum displacement it will undergo. Okay, that is point 2. And coming to the stresses, what we have calculated the elemental stresses, same by analytical, by using the formula force stress is equal to force by area, and we got it as 10 Newton meter mm square. Same thing we have got in the Ansys approach also, the same. In that way we have done a correlation, and this is for the last reaction results using the Ansys approach. I have calculated, you can see this is the minus 600 Newton. Minus means it is negative. Why? Because if you see our problem, this is the bar, this end we have applied a force of 600 Newton, and this end is fixed, and you will find here the reaction which will be opposite, and that's why it is minus, just to show you opposite direction. Okay, so that is nothing but the reaction we have got. Okay, so this was our method number 2 which I have calculated using the software approach. Okay, so in my next tutorial I will go for my method number 3 for the same problem. That is hand calculation, where I will follow the finite element method using hand, means where we analytically will discretize this problem, we will calculate the elemental stiffness equation, then we will formulate the assembly global stiffness matrix for this problem and apply the boundary condition, and again in this also we will calculate the same, the 3, that is the displacement of this bar subjected to the tensile force, then I will calculate the stress along this bar, then I will calculate the reaction for this bar. So that will be in the next tutorial. Thank you very much. If you have any doubt, please let me know. Thank you all. Thank you all.